Good morning everyone. I am Phil Johnson dito Pagano and I'm here to perform laboratory activity number 1, the first measurement in NI DAQ devices. So for the first objective, use NI measurement and automation explorer to examine, configure and simulate NI hardware. Number 2, second objective is to verify that the input output of your DAQ device behaves correctly. So for the part 1, using NIMAX to examine a DAQ device. So for the first procedure, launch NIMAX from the Windows Start menu. So we just launch. We wait. Second is to create simulated hardware. In the NIMAX, select the devices and interfaces, and then click Create New. After this, we we create new dialog box and select simulated NIDAQ MX device or modular instrument, and then click finish. So this one, then finish. Expand the M series DAQ tree and select NIPCI-6221 and click OK. M series and NIPCI 6221, then click OK. After that, this one, that is the added device. Then under the settings section, click the device pinouts and explore the pinout information. But before this, we change this to PCI 6221. Then we go to device pinouts. So this is the device pinouts of PCI 6221 pin. Close the dialog box when you're finished, but let's explore this first. So list all the pins that can be used as input and output port. Tabulate the pin on the type of or the type of signal. So we will determine the pins that can be used as input and output here, and we should identify if that is a digital or analog. So for the pins, here in my laboratory report, um, he, uh, here is the table for the pins that can be used as input and output port. This one, analog input ground, is analog signal, and here from this to this is an analog signal to AOGND, or analog output ground. Analog signal is an analog signal. Analog output channels is an analog signal. Digital ground signal is a digital signal. Digital IO channels from this one to this is a digital signal. A digital APFI OPI.O is a digital signal from this to this. So sorry, if these are all can be found here. For example, this AL, this analog input channels can be found this one, pin 68. Yes. So after that, for the part 2, click the test panels tab on the settings window pane. Windows, this one. So here, I just wait. So here, validate the analog input of your device. So that's one. Make sure that the analog input is selected in the test panels. So there, we're correct. Select PCI 6221 AI0 from channel control, which corresponds to the AI0 pin of the device. The temporary connected. Change mode to continuous one. Oh, sorry. Continuous. So sample and change, then click. Yeah, that's correct. Then we just start. So that are the waves, that are the outputs of that. Now for the question, capture at least three waveform signal. So what did I observe to the waveform in the graph? So here in my lab report. So x-axis represents amplitude and y-axis represents samples chart. So for the part 2, I mean the question 2, change samples to read to other values 5,000 or 10,000, then start the acquisition. Let's change this to 5,000. Then let's start. Then we observe what are the changes. That one, it has a different waveform. You see, it has a different waveform compared to what we had earlier. Then this change to 10,000. 1 2. Then let's start again. So it's also different. It will also be different. Just wait there. So capture the acquired signal, how the samples to read values affects the. So in my explanation here, as observed on the graph, the higher the sample rate reading, so the higher this one, the denser the graph goes, as we observe on the waveform. Yeah, so that's it.